Can you survive a nuclear attack? A nuclear bomb is not just one giant explosion like you see in movies. It is actually several disasters happening one after another. First comes a blinding flash of light, then extreme heat, then a devastating pressure wave. And finally, the most insidious part kicks in, radioactive fallout. So, is it possible to survive a nuclear attack? Yes. If you are not at the exact center of the blast, it may be possible. But this is not only about luck. It is about what you do in the first few minutes after the explosion. Emergency preparedness and public health agencies in the United States have repeated the same advice for years. Get inside, stay inside, and follow official updates. Especially in the first 24 hours, that decision can make a huge difference in whether you live or die. But first, let's understand how this thing actually works. At its core, it is not magic. It is the energy locked inside the atomic nucleus. At first, scientists faced a major problem when trying to break apart the nucleus. Using positively charged particles was incredibly difficult. Why? Because the nucleus itself is positively charged, so like charges repel each other. And then a brilliant but simple idea appeared. Let's hit it with a neutron. Because a neutron has no electric charge. It is not pushed away by the nucleus. It can get close much more easily. That is why the real key that opened the door to nuclear fission was the neutron. When a neutron strikes a heavy atomic nucleus, that nucleus can split in two. That process is called fission. But the truly terrifying part begins right there. When the nucleus splits, it does not just release energy, it also releases new neutrons. Those neutrons fly outward and hit other nuclei. Those split too. Then, even more neutrons are released. And that is how a chain reaction begins. So a nuclear bomb is not just one atom splitting apart. Once the process starts, the neutrons thrown into the surroundings keep splitting more nuclei one after another. And the energy locked inside matter is suddenly unleashed in an unimaginably short moment. What makes this even more disturbing is this. Before the first atomic bomb was ever detonated, one of the biggest fears among scientists was that the chain reaction might somehow spiral out of control. At one point, there were even discussions, however unlikely, about whether it could ignite the atmosphere itself. In the end, that possibility was dismissed as effectively impossible. But the fact that this fear even existed shows how dangerous a door humanity was opening. And let's correct one of the most common myths. Einstein did not invent the atomic bomb. Einstein was not the creator of the bomb. He was one of the figures who helped warn President Roosevelt by signing the famous letter prepared by Leo Szilard. So he was not the man who designed the bomb or ran the Manhattan Project. He was one of the people who helped move the seriousness of the issue into politics. Now let's get to the most important part. What happens when a nuclear bomb goes off? A nuclear explosion is not one single moment. It arrives in stages. First comes the blinding light, bright enough to cause temporary blindness. If you are close enough, it can leave permanent damage. Then comes the extreme heat. That heat can cause severe burns and ignite fires over a worsened area. Then the blast wave hits. It smashes windows, walls, vehicles, buildings, and human bodies. And after the explosion, radioactive particles rise into the air and begin falling back down. That is called fallout. And unlike what many people imagine, the biggest long-term danger is often not the initial blast itself. It is the fallout. Because those radioactive particles can be carried by the wind for miles. To make this easier to understand, think of the event in 3 circles. One important note, these distances are not universal. They depend on the size of the bomb, whether it detonates on the ground or in the air, and the surrounding environment. But for a commonly used emergency planning model, based on a 10-kiloton urban detonation, the approximate circles look like this. The severe damage zone is about 0.8 kilometers in radius, the moderate damage zone stretches from 0.8 to 1.6 kilometers, and the light damage zone extends from 1.6 to 4.8 kilometers. Dangerous fallout, depending on wind, can spread as far as 16 to 32 kilometers. First circle, instant death. Roughly 0 to 0.8 kilometers from ground zero. That means a central area about 1.6 kilometers across. This is the zone closest to the fireball, the crushing blast pressure, and the most intense heat. Here, the chance of survival is extremely low. Second circle, slow death. Roughly 0.8 to 1.6 kilometers from the center. That means a ring extending from about 1.6 kilometers across to 3.2 kilometers across. People here may not die instantly. But severe burns, collapsing structures, crushing injuries, high doses of radiation, and the fallout that follows can still kill them. Surviving the first seconds does not mean you are safe. Third circle, you might survive. Roughly 1.6 to 4.8 kilometers from the center. That means a ring extending from about 3.2 kilometers across to 9.6 kilometers across. In this area, your odds of surviving the initial blast are much higher. But what happens next depends on your decisions. If you stay outside, fallout can still reach you. If you get indoors quickly, especially into the center of a solid building or into a basement, you can reduce your exposure dramatically. So sometimes the real question is not, did you see the blast? The real question is, did you get inside before the fallout started coming down? And now for the most unsettling part. Across Earth, including tests, humanity has carried out at least 2,056 official nuclear test explosions. That number does not even include the 2 bombs used in war at Hiroshima and Nagasaki. Add those and humanity has triggered at least 2,058 nuclear explosions so far. And even today, the world still has more than 12,000 nuclear warheads. So the question is not just, can you survive a nuclear attack? As the real question is, can humanity actually resist using all of this one day? Because yes, if you are not at ground zero, maybe you can survive. If you get into the right building, shelter in the right place, and follow official instructions, maybe you can make it. But whether we as a species are truly safe in the long run, well, that part is a little harder to say. After all, humanity is a species that has already run the should we wipe ourselves out this time experiment more than 2,000 times. So whether we can survive in the long term is still a little unclear. But hey, at least in this area, we have been remarkably consistent. If you enjoyed this video, don't forget to subscribe to our channel and hit that like button and share it with the people you care about, so the light of science can reach everyone.